Section 2. The Classical Trap for the Mind. Following the advent of quantum mechanics, however, observation and measurement became A. subject to theoretical uncertainty, and B. dependent on the consciousness of the observer. An early statement of this came from London and Bauer in 1939. It is only the consciousness of an I who can separate himself from the system and by virtue of his observation set up a new objectivity. Hodgson comments, if measurement is effected by the first registration on human consciousness, then it is not surprising that the mathematics of quantum physics dealing with the objective world does not represent it. Further, a reasonably clear distinction is drawn between measurement on the one hand and the physical processes which are represented by the mathematics of quantum physics on the other. This philosophy of quantum physics is amplified by Henry Stapp. The proper subject matter of science is not what may or may not be out there, unobserved and unknown to human beings. It is rather what we human beings can know and can do in order to know more. Thus, they formulated their new theory called quantum mechanics or quantum theory around the knowledge acquiring actions of human beings and the knowledge we acquire by performing these actions, rather than around a conjectured causally sufficient mechanical world. The focus of the theory was shifted from one that basically ignored our knowledge to one that is about our knowledge and about the effects of the actions that we take to acquire more knowledge upon what we are able to know. Events in the classical world were governed by Newton's conceptions of materialism and causal determinism. All events were conceived as embedded in endless causal chains, leading to the concept of physical closure. In other words, there were no gaps or spaces in these endless causal chains for forces which were considered non-physical, such as consciousness, to have an effect. The one exception to this was the force of gravity, which was reluctantly accepted as mysteriously acting at a distance. Though, as Stapp points out, quote, Newton himself rejected the idea that gravity could really act at a distance without any intervening carrier. Nevertheless, provisional rules were found that were imagined to control the behavior of these tiny entities, and thus also the objects composed of them. These laws were independent of whether or not anyone was observing the physical universe. They took no special cognizance of any acts of observation performed by human beings, or of any knowledge acquired from such observations, or of the conscious thoughts of human beings. All such things were believed during the reign of classical physics to be completely determined, insofar as they had any physical consequences, by the physically described properties and laws that acted wholly mechanically at the microscopic scale. The most thoroughgoing expression of classical physics' mechanistic and deterministic worldview was articulated by the 18th century French mathematician Pierre Laplace. According to him, the entire universe, including human brains, quote, consists of a few kinds of basic objects moving through space in accordance with Newton's laws of motion, end quote. Stapp describes the sort of world that these beliefs lead to, quote, in classical mechanics, the state of any system at some fixed time t is defined by the location and the velocity of every particle in that system, and by giving also the analogous information about the electromagnetic and gravitational fields. All observers and all their acts of observation are conceived to be simply parts or aspects of the continuously evolving, fully mechanically predetermined, physically described universe. A person's stream of consciousness is considered to be some mysterious but causally irrelevant or redundant byproduct or counterpart of his or her classically conceived and described brain activity, end quote. In other words, classical physics implied total predictability. If all the initial conditions of any system are known, i.e. the position and motion of its objects at any instant of time, plus all the forces acting on it, and all these can be represented as quantities to which purely quantitative mathematical laws can be applied, then the system's position and motion at earlier or later times can be calculated. Within this theoretical framework, Laplace concluded that, given knowledge of the relevant laws and the state of the universe at any one time, then the state of the universe at any other time can be calculated. Such vast knowledge and calculations might be beyond the capacity of human beings, but Laplace was convinced God could certainly achieve them. Newton's law of gravitation enabled calculation of forces operating between two or more particles, given their mass and position. Laplace assumed that any other forces must be similar and that there must be some finite number of quantitative physical laws enabling calculation under any given circumstances. This was a deterministic and mechanistic vision of the universe as a machine. As the physicist David Bohm describes, in this view, the universe can, quote, be reduced completely and perfectly to nothing more than consequences of the operation of an absolute and final set of purely quantitative laws determining the behavior of a few kinds of basic entities or variables, end quote. Intimately related to this determinism was the philosophy of materialist monism. In classical physics, matter is the only form of existence. No other substances or realms were considered or recognized. The world was composed of objects arranged in a huge variety of combinations and states, and all of this was entirely independent of mind and consciousness. But what about brains and minds? In classical physics, there's no place for non-physical causes, so consequently, no place for the effective action of mind upon physically described things. The classical physical world is closed. What happens is wholly determined by physical forces, operating on physical objects in accordance with quantitative physical laws. According to Hodgson, some people still see this view as obviously true. If non-physical causes like mind or mental events could affect physical things, the laws of physics would be violated. Stapp concludes as to the oppressive concept of physical closure as follows, quote, "There is nothing in the principles of classical physics that requires or even hints at the existence of such things as thoughts, ideas, and feelings, and certainly no opening for aspects of nature not determined by the physically describable aspects of nature to intervene and thereby influence the future physically described structure. In fact, it is precisely the absence from classical physics of any notion of experiential type realities, or of any job for them to do, or of any possibility for them to do anything not already done locally by the mechanical elements, that has been the bane of philosophy for 300 years. Eliminating this scientifically unsupported percept of the classical closure of the physical opens the way to a new phase of science-based philosophy. The attitude of classical physics to mind, consciousness, and mental causation can be summarized by the philosophical term Epiphenomenalism. Epiphenomenalism is the view that mental events are caused by physical events in the brain, but have no effects upon any physical events. Behavior is caused by muscles that contract upon receiving nerve impulses, and neural impulses are generated by input from other neurons or from sense organs. All mental events are merely byproducts of real physical processes. Therefore, no non-physical phenomena can have causal effects. William James used the metaphor of a walking man's shadow to illustrate epiphenomenalism. The shadow always accompanies the man's actions, but the shadow has no causal effects on his behavior. And Thomas Huxley made a similar point with his metaphor of the steam train's whistle. The sound of the whistle is produced by the engine, but has no effects on its functioning and performance.